So, howdy calculate. It's about to get all crazy on integration. So, you've had some problems that you couldn't do in the past because we had things like radicals or parentheses raised to a power, and we don't have any rules for those. The only thing that we had a rule for was we could split things, for example, like this, into separate pieces and then integrate each term individually. But I didn't have anything. The minute I put a square down there, now I'm stuck. So we're going to look at a strategy called U substitution that's going to help simplify this so that we can integrate it. And we're going to jump right into the first example. So they've actually set it up for me on this one to give me a hint, but anytime I have a radical, I'm going to need to replace the inside with u. And then what happens is it's going to change what I'm taking the integral with respect to. So the minute I put a u in here, I can't be integrating with respect to x. For that matter, I can't even have that x in it. That means that now everything has to be in terms of u. So I'm going to start by letting that inside stuff, notice over here it's all set up for me, equal u. And then I'm going to take the derivative of u with respect to x. And of course the derivative of 9 is nothing. This will be negative 2x. And then if I solve and get du by itself, I'll have negative 2x dx, because of course this will multiply on both sides. So now the integral is going to look like this, and it'll be the square root of u. And then I notice, oh look, this negative 2x dx, I can replace that with du. And then I could simplify this. This is really u to the 1/2. Oh my goodness, look at that. I have a single term. I'm going to power it back up. So I'll have u to the 3/2 and divide by 3/2. And of course, since it's indefinite, don't forget my vitamin C. And if I simplify that properly, I'll multiply each top and bottom by 2, so I'll have 2/3 u to the 3/2 plus c. And then I can put what u was back in. And so remember, all the way back up here, u was 9 minus x squared, and that's to the 3/2 plus c. That wasn't so bad. Let's do another one. So again, on this one, oh, by the way, I'm experimenting to see if the microphone helps. So on this one, they already told me the substitution to make, but I could have seen that because I have a parentheses that's being powered. And so if I don't want to have to multiply that all out, then I'm going to try a u substitution and see if that makes the process easier. So again, if I'm changing this to u cubed, then all of these other variables need to be now in terms of u. So I'm going to take the derivative over here on my u substitution. And of course, derivative of 1 is 0. Power down, I'll have negative 4x. And this was with respect to x. So of course, again, if I multiply both sides by dx, then du is negative 4x dx. And oh my gosh, look, that's all of that stuff. So I'm going to be plugging in du. And now I can integrate, so I'm going to power back up. Oops, I didn't mean to write an integral symbol. So I'm going to power back up. So I'll have u to the 4th divided by 4 plus my vitamin C.